David Delorme é vice-presidente de Desenvolvimento de Negócios para as Américas na Mincon. No primeiro episódio da segunda temporada do Fundcast, tivemos a oportunidade de recebê-lo para uma conversa sobre a atuação global da empresa, a tecnologia direcionada ao setor de fundações e casos emblemáticos. Sejam bem-vindos à segunda temporada do Fundcast.
Welcome to another episode of the second season of Fundcast. In this series, we're bringing in key industry professionals for deep discussions on foundation and civil engineering. Today, we have a special international guest, David Delorme, Vice-president of Business Development for the Americas at Mincon Group. David, thank you very much for accepting our invitation, and it's a pleasure to have you here in our studio. Well, Mincon is a globally recognized company specializing in advanced drilling solutions, particularly for foundation applications in complex environments. While its presence in the US is strong, it is still growing in Brazil, and today we explore how its technology can impact our industry. So, David, the idea in this season 2 is to start the conversation, trying to get information from you before even you got to Mincon, how you got to the industry itself. So it's like David's path into the industry. So I'll make some questions that we can state and discuss. So David, you have a long-standing career in the foundation drilling sector. Tell us how you got started in this industry and how your journey led you to your current role at Mincon.
Yes, well, first of all, thank you for the time. That's great to be here. Well, how I started in the industry is not that I was born and dreaming about drilling. So I didn't know about drilling until I found my first job. So I'm a French citizen, and at the end of my studies, I moved to Finland for my last year of studies. I was studying international technical business, so that was my trade. And the last year, I had the possibility to spend it abroad to learn English with the French people. And when I graduated, for personal reason, I wanted to stay in Finland. So I looked for companies that were looking for someone who wanted to work internationally, who had 2 languages beside English to bring to the company. And I found my first employer, and that's how I entered drilling. As I said, I didn't have any idea. So the company was manufacturing drilling tools, consumables for drilling. But that's how I went there.
Very well. So you had the opportunity to work with different markets and technologies. And what has been the most exciting aspect of your journey so far?
Well, I would say it's the role I'm having now, which in the geotechnical industry is allowing me to be involved in projects which are very exciting. They are exciting not only because of the challenges it brings, but also because of the project themselves. They are very interesting projects. So I think geotech has been very interesting for me.
And we must say that probably you are involved with very nice projects, as you say, because the tool that Mincon developed is a very special one. So when you were called to do the job, is because there's something different that needs an extra attention, and that. So I believe should be exciting to join these kind of projects. And I think we can turn our conversation now to the market in the industry trends. So as Vice President of Business Development for the Americas, you have a broad view of the construction and geotechnical industry across North, Central, and South America. And what trends do you see emerging in these regions?
I'd say if you take the whole area globally, it's diameters. It's getting larger. There used to be smaller piles being installed, and now I'm talking about down the hole drilling, which is what we do. Especially there, the trend is going to the bigger diameters, and in many places, I'd say the easier ground to be drilled are already occupied. So now the hardest conditions are coming, and luckily the technology that we have is allowing to go to these spaces.
Oh, that's very nice. Last year when I met you in Dallas, in the conference, I saw in your booth you had correct me if I'm wrong, but I think it was the 1.5 diameter.
Yes.
Large.
Correct.
That sample tool that you have. That's amazing to see how big we can go, even drilling rock of this quality of drilling. So,
yes.
And it's the largest that you have now,
yeah.
right?
So, when we spoke before about the cool things, I have the luck to be involved. That's part of it, the world record that Mincon is holding. So we had a project where we drilled 60-inch, which is 1.5 meter.
Mm-hmm.
We drilled 60 piles. The longest was about 30 meters of overburden, 8 meters with a casing in rock, and then 3 meters rock socket, just bare rock socket. And that was, and still, the world record for this size with a single hammer. So that's really interesting to be involved.
That's an amazing project.
Yeah, that was good.
Very good to know about that. And are there specific markets that stand out in terms of innovation and adoption of new technologies?
I would say in the Americas, Canada and US are really taking on new technologies, and I think I see a switch in US because in the prior to that, US was very conservative, and it's been probably 10 years that there's been as a new innovation and new maybe understanding of coming technology, and the contractors in there are really understanding to use these new technologies, and that helps the construction because we are not involved in the design of the piles, but we're involved in the installation of the piles, and it's been pretty good to see.
It's good that you mentioned that you are involved in the installation, because you offer this support during the construction, which is very important because lots of the construction companies, they do not know how specifically use your tool. So there are some tricks that you might need to teach them how to.
Yeah, I think it's essential that we as a manufacturer, we can have the best product in the world. If we're not using it properly, it's gonna do no good. So it's a bit like a car. You have a nicest car ever. You put it to someone who doesn't know how to drive. What is he gonna do with this nice car? Nothing. So with this understanding, when we go to a project with a contractor that has never used our system, we give him support to start, and we explain how it works. When there is projects which are a bit more complex than I would say standard project, even though there is no standard project, but something a bit more special, we are much more involved as well in the design, in the support, in all the way. So that's what we try to do.
It's pretty good. Very good to have the support. and we will mention that after in our local case. But let me make another question for you still about market. And what difference do you see between the U.S. and Latin American markets when it comes to foundation for solutions? If there are any.
No, there is. And I see there is also a good evolution from Latin America, which is the understanding that sometimes you need to invest in tooling, because this tooling will allow you to complete a project faster and just to complete the project. And before, there was not this understanding. Before I have always heard contractors telling me in here, well, it's a nice technology, but not for here because it's too expensive. And, if it goes faster, it doesn't matter because the labor is cheap in here. I have been told that from a Brazilian contractor, actually. But now there is this understanding that, well, we're going to pay the tools more in front. It's more expensive than the traditional way we used to do it. But when we use a product in the operation, we're going to save so much money. So much money in labor, also in just simple gas. When you feed a compressors 5 days instead of 1 day, it's a bit more cost. And then the idea that we're going to complete this particular project, so we can move on to a new project. So you can do more project by being more efficient. So that is a mentality that is now appearing in here, which is really good for the industry in here.
Very well. I think we can change the subject for something that's interesting, particularly for me, which is the Mincon's global presence and the Brazilian market. And correct me if I'm wrong, but Mincon is an Irish company with a strong footprint in North America. But how do you see its expansion into Latin America, particularly in Brazil?
So Mincon, the company Mincon, was founded in 1977 by Paddy and Mary Purcell in Shannon Island. And since that, the company has been strongly involved already in mining and well drilling. Okay, and in 2017, that's when the company acquired a manufacturer in Finland and came strongly in the geotechnical construction industry. So the reason I said that is because Mincon is already strongly involved in Latin America in mining. Mm-hmm. We have a company in Chile, we have a company in Peru, and we have someone, as you know, Alexei, in Brazil. Now, going forward, going more to the geotech side, Brazil is very interesting for us. It's a big country, large population. There is a need for infrastructures, and like we spoke before, the easier places are taken. So now we discover the challenged areas. Okay, so we know that we have the right solution, and that's where we put our efforts in here.
Very well. So how does the Brazilian market compare to others that you have worked with, if you already have an idea about?
Well, that's what I said before. It is a bit of a challenge to change the mentalities, even though, as I said, they are changing already. But as you know, importing products anyway in Brazil is something difficult. There is so many import duties, taxes, and it's not easy. But we found our way, And it's an exciting but challenging market.
So I've met you before, I know, but I'll make the question for you to. Have you had the chance to visit Brazil before? What are your impressions?
Well, yes, I have visited many times the country. So in the beginning of my career, it was more oriented to the mining side. And now it's more the geotech industry. As I said, it's a very large country. There is different, as you well know, there is different geology, different challenges depending on where you go in the country, different cultures in the same country, because people from the west are going to be different from the east, north, and south. So there is a different understanding. And now most of our activities in the populated areas. So we have not been yet, or I have not been in the areas which are a bit different.
Let's talk about Mincon technologies and solutions. And I think it's very good for us to talk about the evolution of Mincon. So Mincon was founded in 1977 and has grown into a major player in the drilling industry. Can you share a bit about how the company has evolved over the years?
Yeah. So the company started in Shannon. Paddy and Mary Purcell founded the company, and Mincon started to manufacture spare parts for top hammer drifter. So a very different business. But in 1980, there was an understanding that there is a need for down-the-hole hammer, which was a technology that was already existing, but there was not so many players in the market. And so Mincon started to develop their own technology. Then, a couple of years after, Mincon started manufacturing also in Australia, still in the industry, more oriented to the mining side. After that, a company was incorporated as well in USA. And basically from there, it kind of like lasted a long time before going to Africa. So the company opened service centers and their own branches in different parts of the world. And along those years, the portfolio of product grew. And there has always been the same logic at Mincon is we need to grow by industry. So we want to serve better the industry we're already in. There is no, opportunities are all over the place. There is opportunities everywhere, but who are we? We are a company manufacturing drilling tools consumable for hard rock drilling. So that's with this logic we have developed. So as I said, we were involved in mining, then in water well drilling, and we went public a couple of years ago in 2013, and this allowed us to again grow our portfolio of product, but also to have more service center. As we said before, we like to service the customer, to offer support to our product, and basically all. Well, sorry, I'm just lost in my mind. Sorry.
Have some water.
Yeah, I think. Yeah. So after listing the company, we basically had the possibility to grow our portfolio of product and to open different service centers and support centers across the globe. And In 2017, we acquired a company in Finland called PPV, and PPV was specialized in geotech. But it was a very small company with good technology. But to grow a business globally was, for them, a bit of a challenge. So I think this marriage was perfect because we offer this international side network that they didn't have. So with this acquisition, Mincon entered strongly the geotech side. And since that, the range of the spiral flush and large diameter has really, really expanded. So yeah, that's how we got where we are now.
That was a very good explanation of the company. That really going to be very... I think we're going to repeat ourselves again, but let me try that. What are Mincon's key markets today, and where does Brazil fit in this global strategy?
So, Mincon main market, you can look at market geographically or by segments, okay? And we have a strong presence, of course, in Europe, as we manufacture most of our product in there. But we do also have a strong presence in Australia, in Africa, and of course in Americas, especially in North America. I think the biggest market that we have at the moment is the USA. Okay, and in Latin America, as I said before, we have a strong activity in Chile and Peru, and we count on developing strongly Brazil because of the potential, the project to come, and the solution we offer. I think there is a good match to marry both of them. So that's where we are.
Perfect. I think we're going to head now to I must say, it's the part that I'm most excited with, which is the spiral flush technology, which I really think it's a game changer for urban areas.
Yes.
So let me start with this. One of Mincon's most innovative solutions is the spiral flush, and a technology designed to improve drilling efficiency while reducing impacts on the surrounding structures. I believe most should be unfamiliar with the spiral flush. Could you explain what makes it different from traditional drilling methods?
Yeah. So there's two things about the spiral flush. So that's the system itself. Okay, and I will present first the idea of a casing advancement system, and then I will present the benefit of the spiral flush compared to the other solutions available. So the idea is that you have a ring bit and a casing shoe on the ring bit. You have a pilot, and the pilot is going to be mounted on a downhole hammer, on the shock absorber, depending on the size, with rods linked to the machine. Then you have, as I said, the ring that is going to be welded to the casing. Okay. The pilot is going to be driven through the casing until the ring, and it's going to connect with the ring. And it's going to take the ring into percussion and rotation so that you can drill the hole and at the same time pull down the casing. So the advantage obviously is that if the hole is collapsing, casing it will prevent this collapsing. And in the same time, as we're drilling, we're taking the cuttings out, so we're cleaning the inside of the casing. When we're done, when we have installed the casing to the desired depth, we rotate to the left, the pilot will disconnect from the ring, and we can pull the pilot out. So that's how we are installing casing while drilling. This is allowing us to drill in difficult conditions. If there is only sand and there is no rock, I think it's a bit of an overkill. But if you have boulders, if you have different layers, and especially if you need to embed the casing into the rock, this is the perfect solution because that's what it will do. It's meant to drill hard rock, okay? So now, it is beautiful, but the down-the-hole technology is so that the principle of working is you have compressed air, okay? So this compressed air is gonna move, is gonna be injected to the hammer, it's gonna actuate the piston in the hammer, and this compressed, and the piston is gonna hit on the shank of the bit, okay? And then this air is gonna be recycled to flush the cuttings out. So basically to clean the face of the drilling so that you can hit fresh rock. And this is a normal down-the-hole bit, standard down-the-hole bit. So you see there is some holes in the face, okay? So this compressed air is gonna go out in the rock, on the ground. It's gonna bounce in the ground, on the rock, and go out with the cuttings, okay? So that's the theory, because when you're in hard rock, that's what it does. So that's why. But when we are in overburden, this compressed air has a tendency to escape all over the place. So you may be drilling in here, and 10 meters away, you see air escaping, all the way. And this is, of course, dangerous for existing buildings, surrounding foundations. You may disturb the surroundings. So what we have created is called the spiral flush. So if you see the system, you don't see any flushing holes. Okay, so our flushing holes are not going towards the ground. At no moment we have compressed air going directly to the ground. Instead of that, our flushing holes are going sideways, okay? And we also have holes in the grooves, oriented upward. And the idea is that basically we flush compressed air against our ring. So we know our ring is solid, so nothing will go to the ground. And air with cuttings is going to follow the path of least resistance. So we create back of the bit, we create this path of least resistance, sort of a suction. So we inject air going up, so it is, and it's the natural passage for air with cuttings to go. So it means that we don't use the ground to flush out the cuttings, but we use our system. So air is never out of our system, so we always control the air. So that's how the spiral flush works. And it's a great advantage. It's a very safe method. And the other benefit is, when you're drilling, you are using a certain amount of air to actuate the hammer, but also to flush. So if you lose half of this air in the ground, you're not going to have enough air to flush the cuttings out. So you're going to lose efficiency. So you're going to drill very slowly. You're going to wear out your tools very fast. And sometimes you're not even able to drill. So that's the other benefit of the spiral flush.
You know that first time I met with you and Alexei, and you probably have explained it to me how it works like several times until I understood exactly what you mean. The first thing that got my attention is that, well, you have this shoe which is welded to the casing, but the really good point is that the end part is rotating, so you can drill the rock.
Yes.
So I think that's one of the biggest thing that people do not understand.
Okay.
That's why it's rotating, it's drilling the rock, and you can insert the rock. For me, as a foundation designer, we find this situation sometimes, and we design the pile that when it finds a really hard material, it's sometimes not even rock, but it's something that it's not able to drill with the regular casing. So they change it normally for this kind
for the standard rock bit.
Yes. So they started and drilling this material, and sometimes they found rock, and then they find soil again.
Yeah. To
find rock again in another time. So when they do normally in Brazil, what they do is that they just start. We had an initial diameter, and it go down when you go to the first bit. Then you have to drill soil again, so you have another small diameter, and then the end one in the rock. So you start, and sometimes you lose more than 200 millimeters of diameter, and it might be a lot. We can work with that, but you lose a lot of material. Your pile is not as efficient as anymore. So in this case, you can keep the diameter.
Correct.
So that's very good.
Correct.
And I think your explanation about this spiral flush itself, it's very good. But just we have a camera at the top, so we can see it. So it's very interesting to see how it goes to the side, hits the
ring,
the ring.
Because what is going to be very important every time is, as I mentioned, the ring is made of steel, so we know that we are not depending on the ground, because ground can be whatever. But in case we have even rock, we have fractures in rock, air will escape if we have a traditional flushing. So this ensure us that we choose. We know where we are flushing the compressed air. And you're right. I totally forgot to mention. Maybe it's the habit of saying it, but yes. So I said the pilot is taking in rotation the percussion the ring, but the ring mounted a casing shoe is rotating. So basically, when we rotate the ring, we don't rotate the casing. So the casing never rotates.
That's a very nice thing. When you presented the first time, I was, of course, it's a nice technology, but I was thinking about how can I implement this technology in Brazil in a case that, of course, it's more expensive than the regular ones, but it has this technology. So one thing is important: you don't lose diameter.
Correct. Well, I would say, you know what diameter you're gonna, because inevitably you will lose a bit of diameter because of the inside diameter of the ring.
Yes.
But you know what it is from the beginning, so you work your design according to that, and you won't lose further diameter.
So it's not that much as the other technology.
Correct.
And one of the first things that you mentioned is about when you find boulders. So it's a very good thing. It's a problem for us.
There is a method which is basically rotating the casing with a crown which is already welded or installed in the casing, and you rotate it, and then inside you drill with a down the hole bit. Okay. When you encounter a boulder, so the casing cannot go further, so you are coming through with your bit and you go through the boulder. But often enough, the simple ring that you have installed in the casing is not lasting long time on this boulder. So you have to take the casing out and come back with a new ring, new casing, and grind your way in. So it's a good method, but it's not for every conditions. This is basically an insurance that when you start a hole, you're going to finish the hole, because no matter what there is in front, you're going to drill. Except steel. We don't like steel. When there's steel in the ground, sorry, no can do.
But that's a major problem.
Yeah, well, we've seen that.
All right, I think we saw about. We'll talk later about some application of this part of flush in some cases, and in cities like Balneário Camboriú, where high-rise construction is booming in a densely occupied urban area, preventing damage to neighboring structure is crucial. So the spark flush is really good at this scenario.
Yes, it's where the product really shines, and we have a fairly good example as a market, which is New York, Manhattan. Well, it's very highly populated. There's construction all over the place, high rises all over the place, and there is transportation, subways, and whatnot everywhere. So this technology also allows them to install piles without disturbing the subway or the next high-rise building. So it's a very good system for these conditions.
Very good. Is it do you have a patent on this?
Yes, we do have a patent on the spiral flush, and well, as of now, we are the only one allowed to use it.
So you were talking about New York. I think we have a nice case that you can share with us. But before that, I'm not sure if I'm right on this. Is there a law in New York City that allows or forbids some older technology to be?
No, there is no law per se, but there is a different kind of administration that can say, for this project, I govern what kind of tool can or cannot be used. Mm-hmm. So very often, compressed air is banned from projects because of what I mentioned. If you're very close to infrastructures governed by transportation administration, they will say, yeah, you can install the pulse, but no air. So in certain cases, it has been a challenge, because how do you do without the use of down-the-hole technology? This system has been accepted in several projects, despite the fact that it's a down-the-hole system, but because of the spiral flush, the engineers have recognized that, hey, it's a safe system to be used, so they allowed the use of this system. And yeah, it's for the contractor also a guarantee that the project will be done on time.
Good. Bill, can you share the?
Yeah.
I'm not sure how you're gonna. Probably we'll look to them and then you explain that, and during the edit you probably make a full screen of the.
Sure.
Anyway. So that's the case in New York?
Yes, that's a project which is in 7 Platte and southern Manhattan, the financial district. And basically, it's extremely busy area. It's busy. There is buildings all over the place that have been built years ago. The foundation were different. Sometimes there is friction piles. So friction piles, if you remove what create the friction in the pulse doesn't do any good. So that's why you don't want to flush air in the other buildings. So in this case, there was a very small land, and everything is built upward. You don't have space to build horizontally. So they needed to install or to build a new skyscraper or high-rise building between 2 existing high-rises. And the challenge was that they needed to install 29 piles of 900 millimeters, about 80 feet, which is about, give or take, 20 meters or 25 meters deep. So they needed to do that to reach the bedrock, embed the casing in the rock, and then go through the casing with a 760 millimeter bit to drill a rock socket. Okay, but they didn't know how to do it because there was boulders, and you needed to embed the casing in the rock. So the solution what they chose was basically to go with this system, like you can see on the screen, the integrated system, which is this one, the integrated system, and our ring, drill the casing first. So as I said, very close to the building, as you can see. And when they were done, take the pallet out and came back with a rock bit, draining the rock socket through the ring. I like this picture because it shows how close we can get to the building. Because it doesn't really show when you see the ring near the building, but that's a 900 millimeter casing. So it's a big casing. It's using about 4,000 CFM at 18 bars. So it's a pressurized air. It's a good amount of air that, if not controlled, would go all over the place. We had the ground was basically sand, a bit of clay, and some boulders. So it's a perfect conditions if you don't have the right tool. So in that sense, it was a good project, and now there is a nice building instead of this top side.
It's a very nice case to show. So it's particularly important how the spark flush helped them because, as you say, sand and boulders, and otherwise, if they were working strict with this, and you have a problem.
Well, this building in there might not be there anymore. So how they use this? So in this, they use, excuse me, as you see, it's a pretty clean drop side actually. So they used reverse circulation technology, which is very much used in large diameter. It allows us to drill and collect the cuttings in the same time. This customer used, as you see, a Delorme machine with RC, like a reverse circulation conversion kit from Birmingham. But that was a nice project.
Very good. Do you have more pictures? That's it. So the next one would be our local one.
Yeah.
David, you mentioned before about the reverse circulation. Can you tell us more about what the difference between reverse circulation, direct circulation, just to make sure everyone is on the same page?
So the standard way of working is called direct circulation. So basically, coming back to the example, you drill your hole, and all the cuttings are coming inside the casing, between the drill rod and the casing, and they get out on top of the casing freely. So the casing are getting out from the casing. The cuttings are getting out from the casing, sorry. Reverse circulation is a bit different. When you're drilling, you don't use standard drill pipe or standard rotary head. You use double rotary head and double wall drill pipe. You also have so-called interchange. Okay, so what you do is your cuttings, the bottom of your drill is the same. Your cuttings are getting out between the casing and the tubes, but then there is so-called an umbrella with an interchange. So the umbrella is sealing the ID of the casing and prevent the cuttings to go up. And at this stage, that's where the interchange is important, because the cuttings can't go up, but they can go in the interchange, inside the interchange. And then they go inside the drill pipe, the double wall drill pipe, and they go up, collected by the double rotary head, the RC rotary head, sorry. And we collect all the cuttings, and we can discharge the cuttings as we want. So this allows us to go deeper, to use a bit less air, and especially to go large diameter, because we don't need to have oversized drill pipes and so on. So it's a good technology, especially for large diameters. And for that, as mentioned, you need to have a bit modified. You need to have an RC system, so it's not standard, but it's a very good way to drill big diameters.
It's a very good advancement. Yeah.
It's a good advancement, yes, in the industry. And as you have seen in the example of these 7 plat, it's a clean drilling. You collect everything with your drilling, so you don't have a job site that is looking too dirty.
I've seen a case that I think Alexei, he shared with me an image. As far as I remember, I think everything went to a truck. You can make all the things.
Correct. So there's cases where, depending on the layout of the job site, but when we can actually collect all the cuttings, put that on the truck, and then the truck take it to the recycling or to a site where it can be stored. So yeah, it's a good technology. So
we also have a nice case to present that is here in our city, in Balneário Camboriú. I think it's a good opportunity for you to explain. And it was a problem. We had a problem there because, again, the air escaping from the sides and probably causing trouble in our neighbors. So we brought your technology, and now we are working, and it's doing very well.
Yeah.
So I think you can spin it a little bit.
Yeah. So this is the Hide project from Embraer. So sorry for my pronunciation, but so they had 114 piles to drill, and the challenge was somehow fairly similar to what we presented before. As they were drilling in sand with boulders. So the method that was used before was that, okay, we rotate the casing, and when we hit refusal, we go down the whole standard down the whole technology, we drill. But the problem is they saw air escaping side of the hole. So they knew that air was traveling all over the place. They tried to put some concrete in there to kind of like reduce the effect of air escaping, but it just didn't work out. So the idea is that with your help, we were able to convince them to use our technology. And now they're using our retrieval system in the size of 355 millimeters. And they're drilling the casing down to 16 or 20 meters. After that, they take the pilot out, as I said, and they go back inside to drill rock socket. So during the first, I think the customer was a bit reluctant or wondering if that's going to work. But after the first holes, he noticed that, hey, air is not going anywhere. We're drilling, even though we are facing hard material, still the casing is advancing well. So that's a good project for us.
Yes.
That's a very good project.
Well, for me, it was very good because it made us sure that we were not causing any trouble to the neighbors, because it's really, the air really stayed in the case.
Yes.
So it really, really worked. And it's very important for us. Is the first case that we can apply in the design of ours, their technology, and for us it was very, very nice. And well, I hope we can use it in other cases. But as you said before, Brazil is a tricky place for most of taxes and everything to bring, as is important. So it's not cheap, but we need to understand. Sometimes we may need to use it. It might be no other solution.
Yeah, well, actually there is, because construction has always been done. So there is ways to go, but there is efficient way, or there is sometimes the older way, which is working but not so efficiently, not so fast. This allows really to be efficient in very difficult conditions. As I said, once there is an understanding that we will invest in product, in consumable before, but that will allow us not to have troubles after. That will allow us to go fast. But this is where we have to be. Cost of a product, the price of product, that doesn't mean anything. We need to think about the entire lifetime of a product, from the purchasing to the use of the product. And this is what we tend to forget. So that there is going to be a cost to use the product, to run it. So that's what we're trying to bring.
You know that as a foundation designer, we cannot look to the problem that we have only looking, oh, I need a pile to be embedded in rock for these meters. And it's not about that anymore. We need to check the condition of the construction, whether we're going to make trouble to our neighbors, or even sometimes in the future, maybe we don't have like a really sensitive foundation. We have you mentioned in New York, you have like a tall building with piles, but floating piles are a lot of friction on those piles, and it's not a sensitive foundation, but can be sensitive if you use the wrong technology. You can go wrong. People sometimes look to the neighbors and only ask, oh, they have a spread foundation here, a sensitive one, then we need to go to a special. That's not only about this. Yeah. We might have some tricky on even stronger foundations.
Yeah,
it's very good.
But I would add, I think it's very important for you as a designer to know what technology is available, so that when you design your pile, as you said, you cannot only think of the design of the resistance of the pile itself. You have to think the surrounding, and of course it's beneficial as well because you know that what you're designing is constructible. Because in how many projects we go, and there hasn't been this discussion before or this understanding before from the designer. So the pile is great, and the pile is going to work, and it's going to offer what needs to be offered, but it's not constructible because the whole thinking hasn't been covering the installation of the pile. So it's really important that you are very interested by the new technologies in general.
We need to be part of the discussion. We need to be close to the contractor, close to the drilling manufacturing, and so on. And then, well, what we're talking about is power flush, which is you have a patent on that. Do you have Mincon is currently working developing any new products for the foundation sector?
We have plenty of projects ongoing. We have a project which is underwater foundation. It's a bit of a different market, but it's for the aeolian, the windmill, offshore windmills. So we have developed the technology with an Irish company, in cooperation with an Irish company, how to install foundation underwater. So that's a mix of this technology and other technologies what we own. For the pure foundation, as we are speaking, we are developing a hammer, which is a low pressure hammer for large diameter. Very large diameter for downhole drilling, up to 1.8 meter. So the technology we have already tested. Now it's entering the second phase of the testing. So it's purely for hard rock drilling for now. So it would be for drilling rock socket when the casing is already installed. But I think it will be a game changer for this very large rock socket.
Well, David, we're heading now to the closing remarks here, and David, it was a pleasure having you here in Fundcast. It's very good to hear from you. I mean, I heard this explanation about technology several times, but always good to understand it better. And I hope we can make other cases in Brazil to work with this technology, which I think is really important. And thank you very much for your time here.
Well, then thank you for the time you allowed us to have. And I'm fairly sure we'll have a project together. I may have forgotten a lot of things in my explanation, so just you know where to find me if you need me. So.
Thank you very much.
Thank you.